MHL functions, section 3.4. Today we'll be discussing the transformations of cubic and quartic functions. So, a couple of key ideas. The polynomial function can be graphed by applying transformations to the graph of the parent function, and each point on the graph of the parent function has the following changes. This is a formula that you can use to apply the changes. And by now you should be familiar with this formula right here, the basic form of the polynomial function, and you should also be familiar with what each part does. So a, k, x, d, n, and c, you should be familiar with what each of these parts do. And when we use transformations to graph a function in the fewest steps, you can apply a and k together, and then c and d together. So a and k would be the vertical and horizontal structure compression, and then you can use c and d, which would be the vertical and horizontal translation. So a couple things you need to know. For the case of ln y is equal to a times k times x minus d to the power of n plus c. So a is the vertical structure compression and possibly a vertical reflection. So it would be a vertical reflection if the a value is negative. K is the horizontal structure compression and possibly the horizontal reflection if k is negative. And again, with k, you're always looking at 1 over k for the value for the factor that you are stretching or compressing by. For D, it's the horizontal translation, and for C, it's the vertical translation. Okay, we know this already. So now we're going to match each function with the most likely graph and explain our reasoning. Okay, so a couple things you want to do here. You want to first of all look at the equations we're given, and we're going to look at the characteristics of those equations and then match them to the graph. So for A, we can see that this is a cubic with the degree 3. That there's a horizontal translation right 3 units, that there's a vertical stretch by a factor of 2, and that there's a vertical translation up 1 unit. So that leaves us with these two functions to consider, B and C. But since we know that it's positive and that there's no reflection occurring, no vertical reflection occurring, we can confidently say that it's B. So that's how we know that A maps to B in this case, or that A represents B in this case. Okay, then for B, we know that there's a reflection happening, vertical reflection happening. We know that again it's a cubic and that it has a horizontal translation right 1 unit and a vertical translation down 1 unit. So these characteristics match up with graph C. For equation C, we know that it matches to graph A because it's a 4th degree function, it's quartic. And quartic functions can have multiple forms. It can have this form right here. It can also look kind of like a W, but in this case it matches the function given in graph A, and it also matches based on the vertical stretch that is happening and the vertical translation down 3 units. Then for D, we can see that it matches to graph D, again because it's quartic and it matches the reflection that's happening, the stretch that's happening vertically, and the vertical translation up 4 units. Okay, so let's go to example 2. So it says state the parent function that must be transformed to create the graph of each of the following functions. Then describe the transformations that must be applied to the parent function. Okay, so for A, we have the parent function being x to the 4, quartic function, vertical stretch by a factor of 5 over 4, and a vertical translation up 3. So you'll notice I have lots of examples on this, and the reason why is because you really need to get comfortable with just looking at the function, being able to pick out right away what the transformations happening are. So this is a really important skill that you're going to use with functions throughout. Alright, so for B, y is equal to 3x minus 4, that's a linear function, so parent function is y is equal to x, vertical stretch by a factor of 3, and vertical translation down 4. For C, y is equal to 3x plus 4 all cubed minus 7, so this is a cubic function, degree 3, so y is equal to x cubed, and then we have a horizontal translation by a factor of, horizontal compression, by a factor of 1/3. So again, remember it's 1 over 3 that we're looking at here. Horizontal translation left 4 because we want to take that 4 out of the bracket, so left 4 units, and a vertical translation down 7 units. Then for D, we have y is equal to x to the 4 as a parent function, vertical reflection across the x-axis, and a horizontal translation left 8 units. Okay, then for E, we have parent function being y is equal to x squared, and again, to see the x squared, you need to multiply the two x's. So basically, if we were to actually expand out the entire function, we would see it having the first term as x squared, second term as something with an x, etc., etc. And then we say there's a vertical reflection across the x-axis due to the negative in front of the 4.8, and then a vertical stretch by a factor of 4.8. Okay, and then for F, our parent function is y is equal to x cubed. And again, with this, you can you can, if you were to expand it out, you would see that there's x to the power 3. And even based on what you see here, you can kind of do some mental math and you can see that it would be a cubic function. The vertical stretch by a factor of 2, we see that. Horizontal stretch by a factor of 5, we see that. And again, because it's 1 over 5, it gives the horizontal stretch by a factor of 5. Horizontal translation left 7, and vertical translation down 4. Perfect. So now we're going to describe the transformations that are applied to the parent function to create these graphs, and then we're going to write the equation of the transformed function. So for A, parent function y equals x cubed. So there was a horizontal translation left 3 units, a vertical translation down 4, and this is what gave us our graph. Y is equal to x plus 3 minus 4. And then for D, there's a vertical reflection across the x-axis, a vertical stretch by a factor of 2, horizontal translation right 3 units, a vertical translation down 4 units, and this gives us our overall function of y is equal to negative 2 times x minus 3 cubed minus 4. Okay, so there's a question from the end of the section. So this is giving us basically the parent function. It's telling us what transformations were applied the first time, and then it's telling us transformations that were applied a second time. And basically what they want us to do is, given the final equation of the function, they want us to tell us what the transformations were after the first time it was transformed. So what we need to do basically is we need to undo everything that was done the second time around. So what I did is I first wrote down the transformations that were made the first and second time. So first time there was a vertical stretch, a horizontal compression, and a vertical translation. So you'll notice they weren't really specific with the translation or the compression or the stretch, like the degrees or the amounts of each stretch or compression or translation that was made. They weren't specific with that because we don't actually need that information in order to answer the question. All we need to do is undo what was done the second time around that they transformed the function. And they gave us the details onto how they transformed it the second time around. So in summary, they performed a vertical reflection, a vertical compression by a factor of 4 over 5, a horizontal compression by a factor of 1 over 2, and a vertical translation down 6 units. So now, based on that, we have our final function. F of x is equal to negative 4 times x plus 3 all squared minus 5. So we need to undo our second step. So basically then what I did is I took our final function and step by step I undid everything that they gave us. So first thing I did is I undid the vertical reflection, so I multiplied the whole thing by minus 1. Then I undid the vertical compression, so I multiplied it by 5 over 4. Then I undid the horizontal compression, so I multiplied it by a half, multiplied the horizontal component by a half, which gives us now so far 5 times 2 times x plus 3 all squared minus 5. And then the last step is to undo the vertical translation. So that's why I added 6 units, so the vertical component. And this gave us an overall function of 5 times 2 times x plus 3 all squared plus 1. Alright, so with that we conclude this section. I hope this video helped, and I hope that you are becoming more and more comfortable with what each little piece in a function signifies. That's going to be a really important skill moving forward. So with that, thanks for watching. If you have any questions, feel free to let us know. And I look forward to seeing you in the next video. Thank you.